Hi there, Mr. Sutton here, bringing you the Algebra 2, either the 4-5 Part 3 homework if you're doing the CP non-honors, or the 5-4 Part 2 homework if you're doing the honors version of this. And then the non-honors we're doing 1 through 3. Honors has problem 4 as well. So this topic is going to be solving polynomials by using the rational roots theorem. For this problem, to solve the polynomial here, we're going to first check to see if there's any common factors we can take out. We've got it all zeroed out, so that's a good first sign. But looking at our common factors, these are all divisible by 2, and we can also take an x out of all these. So if I take out a 2x, that leaves me with an x squared minus 6x plus 9. And now inside here we can factor a little bit more. Things that multiply to 9 and add up to negative 6. That would be, let's see, 1 and 9 doesn't work. 3 and 3 works if they're both negative. So I've got the 2x that I took out initially, and I have an x minus 3 and another x minus 3, so x minus 3 squared, all of that equaling 0. Now setting each of our factors equal to 0 and solving, we have x equals 0 for the 2x here, that zeroes that factor out, and x equals 3 for this other one. And we've got actually a double root of 3. We don't have to spell that out, but it's there. On this one, we have things on both sides of the equation. As a general rule, when in doubt, zero it out works pretty well with solving equations. So let's move everything over to the left side. So I've got 2c to the fourth minus 6c cubed minus 12c squared plus 36c equals 0. Next up, let's see if there's any common factors I can take out. These things are all divisible by, let's see, they're all even, so I can take a 2 out of all of them. And they all have a c, so I can actually take a 2c out. That leaves me with c to the third minus 3c squared minus 6c plus 18. And since I've got 4 terms, I'm going to try to factor this by grouping. So I've got the 2c that I initially took out. And for these first 2 terms now, I can take out a c squared. That leaves me with a c minus 3. For the next 2 terms, I can take out a negative 6. So that's going to leave me with a c and a minus 3 as well. So just to come back to the beginning, we have that 2c that still just keeps following us around. We have a c minus 3 that we can factor out of the stuff inside here. And that leaves the c squared minus 6 for its own parentheses. All right, let's set each of these things equal to 0 and solve. If 2c equals 0, then c equals 0. If c minus 3 equals 0, then c equals 3 is another solution. If c squared minus 6 equals 0, we can say then that c squared equals 6 if we add that to the other side. Then we square root both sides, and we end up with c equals, don't forget your plus or minus, radical 6. Which we can't simplify any further. To get started on solving this equation, let's begin by zeroing things out and subtracting this 14p squared to the left side, and I'll stick it between the p to the fourth and the 40 there. I like to have things in decreasing order of exponents. Now, since I've got 3 terms and the first exponent is twice the second and the last thing is a constant, this is a pattern called quadratic form, where I can basically treat this thing like a quadratic and maybe factor it, but I'm going to use p squared where I would normally just use p. So trying to factor this, let me think of things that multiply to 40 and add up to negative 14. Well, let me think. 1 and 40 doesn't work, 2 and 20 is no good, 4 and 10 works if they're both negative. So instead of writing p minus 4, I'm going to write p squared minus 4, and then I'll write p squared minus 10. Now I'm going to set each of these equal to 0 and solve. If p squared minus 4 equals 0, that means I can write p squared equals 4, if I were to add the 4 to the other side. And then if I square root both sides, I have p equals plus or minus 2. For this one, I can write p squared equals 10. So then p equals plus or minus square root of 10. For this problem, we're going to try and sketch the g function. So we're going to get the x-intercepts, y-intercepts, the end behavior, and the root behavior out of this function, and then we'll put it all together on the graph. First thing I'm going to do if I'm solving for the x-intercepts is I'm going to basically set this equal to 0 and try to factor and solve it. One thing I'll look for is common factors. Now these are all divisible by 2, and if I'm going 2, I might as well take out a negative 2. And also x to the third is the lowest exponent, so I can factor that out as well. So I'll start with a negative 2x cubed coming out of there. This first term now is going to become an x squared if I divide negative 2x to the fifth by negative 2x cubed, so x squared. And then 2x to the fourth divided by negative 2x cubed is going to be a negative 1x to the first. And then finally 40x cubed divided by negative 2x cubed is going to be negative 20. I can factor the stuff inside here a little bit more, so let me bring down this negative 2x cubed just so I don't forget about it. And in here now, numbers that multiply to negative 20 and add up to negative 1. Well, 1 and 20 doesn't work. 2 and 10 is no good. 4 and 5 works if I have a positive 4 and a negative 5. So there's that factorization. Setting each of these factors equal to 0 and solving now, if negative 2x cubed equals 0, just plugging in 0 would zero out that whole first factor. So we have x equals 0. And then negative 4 zeroes out the next factor. And 5 gives us a 0 on that last factor. The y-intercept is the invisible constant of plus 0 over here. That's the same as the x-intercept of 0, so no new material there, but that's okay. We'll just keep going. The end behavior, we start with a negative 2x to the fifth for our lead term. That's a negative x to an odd power. That's going to be a down line. And then for the root behavior, the 0, the negative 4, and the 5 are all coming from odd powers. We have third power, first power, first power. So we're going to be crossing through all of those. Although if we're being technical, we could say we're flattening at 0, but let me just write cross. There we go. So crossing through all of them, just so we're not muddying the waters. But I'm just going to keep in the back of my mind that if I'm being super fancy, I could flatten as I cross at 0 because we have an odd exponent higher than 1. Whether you actually put that in your graph or not, that's up to you. So graphing out my x-intercepts, we've got negative 4, 0, and 5. The y-intercept of 0, 0 is right here. We've already done it. We're starting above the x-axis and ending below the x-axis based on this end behavior. And we're going to be crossing at all 3 x-intercepts. So starting up here, crossing through negative 4, crossing and, if you want, flattening through 0, coming back down and crossing through 5. We end below the x-axis, just like we said we would. To graph this one, let's first factor this out so we can find the x-intercepts. Since we have fourth power, second power, constant sort of pattern going on here, this one's in quadratic form. So we can treat it like a quadratic, only we'll use x squared instead of x when we factor this thing out. So since I've got 81 and 18 here, let me think of numbers that multiply to 81 and add up to negative 18. So that would be, I think, negative 9 and negative 9. So instead of writing x minus 9 quantity squared, I'm going to write x squared minus 9 quantity squared. And if I want, I could actually split this up a little bit more. One of these would go into x plus 3, x minus 3. Since I have 2 of them, I can just do x plus 3 squared, x minus 3 squared. And now setting each of these equal to 0 and solving, we see that x equals negative 3 for this first one and positive 3 for this other one. Let me get a little bit more information now. The y-intercept is going to be this constant of 81 over here. So 0, 81. For the end behavior, we have a lead term of x to the fourth. That's a positive x to an even power. That means that I'm going to have an up parabola sort of look. We're going to be starting and ending above the x-axis. And then finally, for the root behavior, both of these zeros, negative 3 and 3, are coming from squared factors. So that means that we're going to be bouncing at both of those spots. So putting it all together, let's do our x-intercepts, negative 3, positive 3, and the y-intercept, 0, 81, somewhere up here. We're just sketching it. And now we're starting, we said, above the x-axis, and we are bouncing off of negative 3, going through the y-intercept, coming back down and bouncing off of 3, and then going up forever, just like we said we would. We're going to go ahead and graph the p function now. In order to do that, we want to get the x-intercepts. So we're going to try to solve this by factoring. Set it equal to 0 and solve it. So since I have 4 terms and there's no common factors I can take out of everything, I'm going to go straight to grouping. For the first 2 terms, I can take out an x squared. That leaves me with an x and a minus 5. For the next 2 terms, I can take out a negative 4, leaving me with an x and a minus 5 there as well. So now this x minus 5 is a common factor that can come out of everything. And then x squared minus 4 are the leftovers. Going a little bit further, we can split this x squared minus 4 up into x plus 2, x minus 2. And now our zeros, we're going to have 5, negative 2 for this plus 2 here, and positive 2 for the x minus 2. For the y-intercept, we've got this 20 over here, our constant. And then for the end behavior, the lead term is x to the third. That's a positive x to an odd power. So that's going to be an up line kind of end behavior, starting low, ending high. And then for the root behavior, all of our zeros are coming from one power, single power, odd power factors. So we're going to cross through all of those. So starting below the x-axis, well actually let me do my zeros first. So we have negative 2, 2 and 5 somewhere over there. Y-intercept of 20 somewhere up here. And now starting below the x-axis, we're going to cross through negative 2, go through the y-intercept, cross back down through positive 2, turn around, cross through 5, and going up there matches the end behavior that we predicted earlier.